I had this idea a couple months ago and like started researching and learning about it because I heard I went to a Girl Develop It event that was like proposing your first conference talk, which was a really cool event. And one of the pieces of advice they gave was like give a talk on something you know nothing about, and that way you'll have to learn it. So I was like, I know nothing about the Ruby VM, so I'm gonna like give a talk on that. So I started reading about it and learning about it a couple months ago. I went to RubyConf last month, and Aaron Patterson actually gave a talk on the Ruby VM. So if you saw that video, this is not going to be as good, but this is an intro one, so you can definitely look at that later for more in-depth information. So first question is probably, what the heck's a VM, right? A virtual machine is an operating system or application environment that's installed on software which imitates dedicated hardware. Okay, like what does that mean for Ruby really? So basically it turns Ruby code into bytecode. If you were to just write Ruby code just on your computer without having installed Ruby first, it wouldn't know what to do with it. Your machine doesn't know how to take Ruby code and turn it into bytecode. Go for it. So basically, yes, it's like an interpreter or compiler. It takes your code, yep, and makes it into bytecode. And instead of your code running on the machine, it runs on the VM. The bytecode runs specifically on the VM. And this is actually the same for Python as well. So Python code gets interpreted to bytecode and then runs on their VM. And then pretty much the same for JavaScript, but it's on a million different client browsers, which is why you have compatibility issues, because everyone interprets it differently. So it's kind of just like sitting in the background waiting for you to run like Ruby myapp.rb, and then once you do that, it kicks into life, basically. So the Ruby VM is called YARV, which stands for Yet Another Ruby Virtual Machine. It was invented by Koichi Sasada and became the Ruby VM in version 1.9, which was in 2007. Previous to 1.9, it had what was called Matz's Ruby interpreter. That was how the code got interpreted, and that interpreted to C. And Ruby was really, really slow. Ruby still has a reputation of being kind of slow sometimes, but it was especially slow pre 1.9 because it was just completely interpreted, nothing was compiled. And so YARV fixed that problem. The reason why it's called Yet Another, even though it's really our first VM, is because there were 6 or 7 different attempts to create a Ruby VM, and no one was really doing it up to snuff, and then Koichi created this one, and then this one is the one that stuck around. So that's why it's called Yet Another. So before the code actually gets run on YARV, you have to kind of prepare it to get interpreted and run, basically. So the way that's done is the first step is that the code is tokenized. So when you put code in Ruby, it goes through each character and converts them to a series of token that Ruby understands. So if you put in 10, it takes that, and in the background, Ruby says T integer. That's the token that stands for any sort of number. And it kind of has this really cool thing where it'll look at the 1, and then it looks ahead to see if the next one's a numeric value. And if it is, it goes on to the next one and says this is part of the same number. And then it'll look to the next one and see if that's numeric. If it's not numeric, then it jumps back and says, okay, this is our number. So it looks ahead and then jumps back to know when different tokens end, which is really cool. And then after it's tokenized, it parses, which means the tokens are grouped into sentences and phrases that kind of make sense to Ruby. So the instructions are all grouped together. Instead of being a bunch of different tokens, it's kind of grouped together. And again, this is pretty much the same way as it happens in Python as well. So there's kind of a lot of text on this slide. You don't have to read it all, but basically the reason that YARV was created is because compiling is generally a lot faster than interpreting. So pre-Ruby 1.9, everything was completely interpreted. It would parse and tokenize your code, and then it basically it executes one thing at a time. It goes through, and every time it executes your code, it does one thing at a time. And so if you run your code again, it has to do all of that work again every single time. If you compile your code, then it doesn't have to do the work again until the program is changed. So now the way Ruby VM works is similar to how like Java works. The JVM compiles its Java bytecode, and then that bytecode runs in the JVM. That same thing happens with Ruby now, as opposed to it being interpreted to C and then like to machine code. And so I've said compiler versus compiler interpreter a lot, in case a lot of us, don't really know what that means. I certainly didn't before. So the basic definition is that a compiler, like I said, kind of takes it from source code to machine level code once until the program is changed, and the interpreter does the same conversion work every time a statement or function is executed. So it ends up being a lot faster. Like the YARV, when it was created 1.9, was as much as 4 times faster than 1.8, just adding in this compiling step. With all of that being said, Ruby is still classified as an interpreted language. It has what's called an intermediate representation, which combines compiling and interpreting. And again, this is the same with Python, the same with a lot of things in Java. Most so-called interpreted languages do use an intermediate representation because, like I said, it's just so slow for everything to be interpreted that it really can't work that way anymore. So this is a little representation of the abstract syntax tree. So basically what happens is it takes your Ruby code, it parses it, and then makes this little tree of things that it can run through. And this is kind of like the DOM in JavaScript. It's just like a thing that lists out all the things that you have to do and goes through each step. So before 1.9, it traversed the abstract syntax tree and basically read one line at a time. And now it compiles that to YARV bytecode and then runs it. So instead of going through the abstract syntax tree and saying like, okay, class, like this is a class, like, oh, this is this token, this is this token, it just compiles the whole, it still makes the tree, which is why it's interpreted, but then it just compiles that whole tree to bytecode. Yeah. You could write it, and it would run, yes. I invite you to try. Yeah, and there are actually a lot of languages like this. Might look kind of similar. It doesn't even sound like Lisp or Clojure, like everything's surrounded in parentheses. And this is kind of why, because it gets it closer to this. And that's why those languages are a lot of times like faster or more data interpreted, because it's closer to how things like actually run. Like everything in Clojure or Lisp, like your code is data, and this is basically turning your code into data. And so that's kind of how it works.
And then just, if you add a new method or a class, does it immediately get translated, or it's only when it's called and then it's saved after that? It's when it's called, or well,
so it kind of depends on what you're doing. Usually in Ruby, most things are lazy loaded, so they don't get done until they're called. Some things are loaded before they're called, but most things are lazy loaded. So it doesn't make this AST until it's called, and then it like will redo the whole AST. So kind of the cool thing is that you can do this. You can see this on your own with any of your code. There is a thing in Ruby, in IRB, you can go in there and do Ruby VM instruction sequence.compile and put in code, and it'll compile it. So here I've just saved it in a variable called iseq and done compile puts 2 + 2. And then you run a method called disassemble, which is disassemble on it. So iseq.disassemble, and then it prints out the stack trace of what it's actually doing. So the Ruby VM is a stack-based VM, which means it's kind of like some calculators work like this too. Basically, every time when it goes through the AST and it starts running your code, the abstract syntax tree, this thing from before. So when it goes to this and when that's compiled, basically that gets down to this. That's compiled to this. And then the VM takes all of that and it makes kind of this, this stack where it basically pushes each value onto the stack and then when it compiles, or like when it basically like simplifies, like in math. So you have like 2 plus 2, and then when you hit enter, it simplifies it to 4, right? So the Ruby VM does that. So first it pushes self on the stack, then it'll push the 2, then it'll push another 2, and then on the top, you see it's pointing towards opt plus there, that's the plus symbol. So it pushes the plus onto the stack, and then it pops all those values off and pushes a 4 on in its place. So it kind of like does each thing one at a time, and then basically simplifies, just like in math. And that's kind of how it gets your code run. And again, if you've ever looked at like list per closure, this is kind of familiar too, because they put their operators first. Like they'll do plus 2, 2, because your numbers are just an argument to the function plus, right? So you're calling the function plus and then sending the 2 and the 2 as the arguments. And that kind of makes sense as well, because really when Ruby goes to interpret it, it kind of does it backwards, but it does the 2, and then the plus. It's never really in the middle. Like no computer knows how to do it in the middle, you know? That's just for us silly human brains. So there it is that. So you're probably asking like, so what's the point of all this? It's like kind of cool information, but what can you do with it? The biggest thing is debugging moments, like moments where you're like, this code should work and it is not working and this is BS and I hate this. This can really like help you figure that out if you use these like iseq.disassemble, or just know a little bit about how Ruby parses your code and stuff. So we will go through an example of that. So we're here in IRB, which for non-Ruby people is just like a place where you can tool around with Ruby code without actually having to write a program. So actually, just clear this. Okay. So let's say for example, that you had a program where maybe you're getting like an array, like a list of items, and you don't know the classes of the things in that array. And maybe you just want to like print out the classes so you can see what kind of stuff you're getting back. So you start to do like puts, you know, if an empty string comes through the array, it'll do puts that class, and that'll do string, and maybe do puts. That'll do array. But then you get to a hash. An empty hash comes through your thing, and suddenly it says nil class, even though it's a hash. And it's like, what? Like that's supposed to work. Everything else worked. Why didn't that work? That's ridiculous. That's stupid. Maybe. Well, I don't think Ruby does that. A setter? I don't know if Ruby has that in the same. Like, are you saying like tuples or?
That are their width, but they enforce uniqueness.
Oh, we do have sets, but it's not with that notation. It's with the same. Well, you really just do like set.now. So it doesn't think it's a set. You might be able to guess what's happening if you've used a lot of Ruby, but I certainly wouldn't if this was me in the wild. So let's play with it a little more. So let's say if we drop the puts and we just did this dot class hash, it knows. So why does the puts break it? That's stupid. I just want to puts out the name of this thing. So that's stupid. And then let's see, maybe if we just fill it up, like maybe it's just mad because there's nothing in there. So if we put something in there, what syntax error? It doesn't know, like that's a valid hash. Why is it being stupid? So there's actually a gem called Ripper that you can use to see your the parsed code. So if you get into a situation like this in the future where you're like, my code should be working, but it's not working, you can assume it's probably Ruby's not parsing it the way that you think it should be parsing it. So you can require Ripper. And I'm just going to require awesome print, which is just something to make it print awesome. And we'll do So we're just gonna have Ripper print out the parse code for puts blank thing dot class.
That's like string expression.
Yeah, I don't know what that stands for actually. I guess I could have looked it up, but I just thought it was kind of funny, so I just like left it. But so this is the abstract syntax tree for your code. You can at any time use Ripper to like pull it up and be like, oh, this is what Ruby actually thinks is happening. Like that's kind of cool. Obviously, none of this really makes sense, but you can kind of use some intuition to try to figure out what's happening. So we go through, it like starts the program, and then it has the call. Then it has this method add block, which I'm like, well, where did I put a block in? And then it has some arguments. It finally gets the puts, but I don't even see where it's putting like the hash or anything. Then it has this other thing, brace block. So when looking at this, you can say, well, it's saying block like a bunch of times. Maybe Ruby actually thinks that I'm passing a block to puts, because puts can yield to a block. You can pass a function to puts. So it's for non-Ruby people, I don't actually know a good description of that in Python. I'll do it, see if this makes any sense. But basically, what Ruby thinks I'm doing is it thinks I'm doing this. And that's why it's giving me no class. It thinks I'm passing a do end block to puts, because hashes can serve as or curly braces can serve as in replace of do end, you can use curly braces.
So is it thinking you're like creating an empty function, you say a do end block?
Yes, basically. Yeah, it's kind of like a lambda function. It's an anonymous function. It thinks I'm creating an empty anonymous function, basically. So that's why it's doing that, because it's not seeing it as a hash. It's seeing it as an empty anonymous function or an empty block for Ruby's. And so, of course, that's why you also get that syntax error, because it thinks I'm doing puts, do, end. What was it? Like, yeah, obviously that's not valid Ruby code. Inside of a do block, I just have this random like hash rocket for no reason at all. So, so that's what it thinks I'm doing, and that's why Ruby is mad at me. So, if you kind of if you get stuck and don't know how to look at your Ruby code sometimes, or like don't know why your code isn't working, this is definitely a tool that you can use to explore it. So if I instead do now, and I'm actually going to, that's right. Nope. There it goes. So now I just put it in parentheses. So instead of leaving it ambiguous and having a space, because in Ruby, unlike in Python, like anytime you're going to call a function and pass something into it, you have to use the parentheses, right? The parentheses in Ruby are optional, but that does sometimes lead to things like this, where it thought I was doing something completely different than what I was trying to do, because I didn't have the parentheses to say, this is an argument I'm passing to a function. So if you just put the parentheses in and kind of disambiguate it, then instead of where before this was method add, this showed method add block was the token it thought it was going to be, now it says method add argument. So now it knows what I'm actually trying to do. But just a quick example of different things that you can do to kind of use the tools available that shows how you're parsing and tokenizing your code to debug moments when you're like, this is crazy, like this should be working. Another benefit of kind of really understanding the VM is performance optimization. So if you know or can look up how Ruby parses or compiles, or Python or JavaScript different things, then you can know which methods are faster. Like, does it matter if I use a do end or if I use the two curly braces? Is it quicker one way or the other? I don't know. Like, is it faster to use a case statement or to use like an if else? I don't know. Like, but you can, this code is available and you can put it in Ripper and see what kind of abstract syntax tree comes out. And if you're at a point where you really need to make sure you're doing performance optimization, then this can help you do that, because you'll know, okay, Ruby knows how to do this easy, whereas it has to go through 50 different steps to do this thing, you know?
So you tell speed by how many lines?
Basically, yeah. If it has to do, basically, because again, every single line basically is gonna compile down to something that has to push onto the stack and then like evaluate and pop off and do something else. So for everything, you're like really making it do a lot of work to get what you actually need. And it doesn't feel that way sometimes because you run like Ruby myapp.rb and it's so quick. Like, how can it be doing all these different steps? But it's doing a lot of things, and especially with larger programs, or if you were like looping through a huge array or something that had a lot of data, then these things can really, really add up and make your code a lot faster. The other big benefit is metaprogramming. So for non-Rubyists, metaprogramming is one of the things that makes Ruby the most popular. Basically, you can use Ruby to program Ruby. So you can make Ruby do anything you want it to do. The power is in your hands. There's something called monkey patching where you can overwrite the previous classes. So if you have like the string class and you don't want it to actually be a string, like you can completely change the methods on the string class in your program. You should never do that, but you could totally do that if you wanted to. And it's fun. You just mess with people. If you ever want to like really mess with your coworkers, just overwrite the 2S method and have it like do something completely different, and that would be great. After you're settled in your job, cohort fivers. Not the first week, certainly. But if you're going to metaprogram, you really have to understand the way Ruby parses your code and like the way that it puts everything together. Because there are a lot of times when you don't think you're doing something crazy, but you're really like breaking the boundaries of what Ruby it normally expects. Like things with that, like, oh, you just have to put parentheses around that hash in the puts function if you want to call class. Like if you're metaprogramming, stuff like that will come up all the time. Like for example, my boss was teaching me how to some metaprogramming stuff one day, and we were doing like a dynamic method definition. So basically, Ruby has a method called define method that you can use to define other methods, which is great. But we were using that, and it was saying we were defining methods, and then at different points it was saying, oh, I don't see that method basically, and it was because it was under the method that it was under where we were trying to define a new one. Well, usually in Ruby, like the order of your methods don't matter, right? Like Mason for us taught us like, oh, it makes like a blueprint of your class, and then like it runs like the blueprint type thing, right? Turns out that's a lie. But so don't tell Mason I said that though, because I don't want him to be mad at me, but he lied to all of us. Right. Sorry, Mason. But yeah, it turns out that's not actually true, but it's true enough unless you're in a metaprogram, and then it's not true at all. And then you really actually have to know how Ruby like reads your method. So stuff like that. And then the last big thing is knowing when to use what language. So I don't have a lot of slides about this because I didn't want to put too much in and then end up being like this being like a really long talk or anything. But there are a lot of things when you look into the Ruby VM that you start understanding why when they say, like, you know, you might talk to a senior developer and they say, oh, Ruby's not really good for that project. I'm going to use this other one, this other language. You're like, okay, like I believe you, you're more senior than me, but like why, right? So there are a lot of things that, I mean, it all comes down to the Ruby VM, like why it would be good for one project and not for another. So Ruby right now, like I said, there are major speed improvements with YARV. It's not really as slow as people like to make it out for right now. A lot of people say it's about, unless you're like crunching huge data sets or anything, it's about the same speed as Python. But there's still some things, for example, if you wanted to have millions of users all connected to your app all at the same time. Ruby has what's called the global interpreter lock, the GIL, and that means that only one process can be running at a time. They added that to Ruby so that it would be what's called thread safe. It wouldn't basically if you have a program that's not thread safe and you're doing a lot of different calculations, it can literally lose its place. The threads get mixed up and you'll get the wrong answer from mathematical calculations because it'll get confused. You'll add one and then the next thread will start and it won't realize that other thread added one to the number and you will get the wrong number. So Ruby put in the GIL so that didn't happen. And Python actually has the same GIL, the same global interpreter lock. So they're both internally thread safe, but what this means is, again, only one process can ever run at a time. So if you wanted to make an app, say instant messaging application or something where you have millions of users all connected at the same time, only one could ever actually be doing anything at the same time. And it's milliseconds that it takes to do those things. So for a while you don't notice, right? But then that's why Twitter started on Ruby and then could not continue on Ruby when it got faster or when it got bigger because there's no way for Ruby to do that. But if you're a JavaScript developer, Node can totally handle that. Node can have open connections all at one time, and that is fine. There was a really good talk at RubyConf as well called Everything You Know About the GIL is Wrong, and basically the premise of the talk was that the Ruby GIL doesn't actually stop concurrency from happening. You can have multiple threads that have different information, but Ruby cannot have any parallelism, meaning the threads cannot run at the same time. So with that app, Puma gives you 16 by default. I had to spin up 60 to get that to actually run because there are 50 different jobs and you need threads to get different things. So Puma does give you the ability to make that stuff work, but it doesn't. It still doesn't give you. It still can't. Threads still can't run at the same time. So you can have as many threads as you want. Well, not as many because your computer will crash at some point. But you can have a lot of threads, but it still doesn't always give you the ability. It doesn't ever give you the ability to run those threads at the same time. Yes, 16 is the default on Puma, but you can put up as many. You can pass it an argument to put in. Your computer will learn. You can try that though. I encourage you to try. Yeah, so that's just one of the many reasons why it's important to learn about this kind of stuff, because if you don't, you never can do stuff like that. If you don't understand what Ruby is good for and what it's not good for, one day you'll be given an assignment like that and you'll think, oh, I'll use Ruby because I always use Ruby, and you can use it, but that would have been a whole lot easier if I'd used Elixir or something, because then I wouldn't have to manually manage my threads. Manually stopping and starting threads is not cool and is not something that you should be having to do, because then also, what if more jobs come in? I started my Puma server with 60 threads. What if all of a sudden there are 30 more jobs? Now I don't have enough threads to handle them all. It's just going to crap out. So with a lot of different languages like Node or Elixir or Go or Clojure or something like that, it does all that for you because it is built. It doesn't have the GIL that stops you from having parallelism, really. So that's about it. These are some other resources for other languages. You can do that disassemble thing in lots of different languages to see what works. So there's the dis function to see Python bytecode. So if you're writing a Python bytecode, you can totally use the dis function to see it. And I have a link here, and I'll post these slides up so you can do it as well. And then with JavaScript, it's not as easy because nothing's easy in JavaScript. It's one of the core tenets, actually, of JavaScript. But there is an app or a library that someone made called capstone.js. I didn't see a lot of reviews about it, but you can use that to disassemble your code to bytecode if you're interested and want to see. Or like I said, if you have, I think, there are more what moments like that in JavaScript, definitely. So if you come across something and you just have no idea why your code's working, you can always do that to actually see the bytecode. And or why it is or why it isn't. I usually don't know. And then these are just my sources for the thing. So this will all be posted. Most of this stuff, a lot of the stuff came from Ruby Under the Microscope, which is a really good book that gets into the Ruby internals. The stuff that I went over tonight only covers like the first 3 chapters, and obviously not even all of the first 3 chapters, and there's like 8 more chapters in that book. So there is a lot more to learn. And if you're interested, I definitely say like this is a really cool area to get into, because once you learn about this stuff, like you can start contributing to Ruby or Rails or anything, you know? Like you've learned once you like learn how the VM works, that's pretty much the biggest thing to learn, and then you're just off. You can do anything. So, yeah, so that's pretty much it. That's all I have.